Okay, hello, welcome. This is the question 1 for edexcel's S1 June 2015. Okay, so what we're given here, that drawing this table, it's not really relevant for the first part of the question, but I thought I'd make it look nice when I started the question and have a bit of data there. Okay, but it's completely irrelevant to the first part of the question. Okay, we're given this box plot. Okay, we're quite clearly an X marked on the 49 mark, okay. And what we're told, it's the results for angles drawn that were attempted to be 20 degrees by students, and obviously they weren't allowed to use, they weren't allowed to use a protractor, so it's kind of guesses of what the 20-degree angle is, okay. Now we've got an outlier there, they've already calculated that, that is an outlier, but it's key to remember, especially for the first part of the question, that is a result, so you can't discount it because it was an actual result. Okay, so 1A says state the range of this data. Okay, now quite clearly, you know, the range is the biggest number, take the smallest number in that set of data. Okay, now the biggest number you could say is, because you can't really, well, I was trying to build up so you could acknowledge it, but as I say, this 49 here, if you have to read down, you see it's the 49 mark, okay? But you can't discount, that was a result. You can't just say, oh, well, it doesn't fit my hypothesis, so I'll sack it to one side. Well, it was a result. It still happened somehow, so you still got to account for it, okay? So, therefore, the maximum is 49. The minimum value should read to be 9. So, therefore, obviously, the range is 40, okay? So, just testing your result to know what that X point was, okay? So, a lot of students just would have thought, it was 39, it's actually 49, is the maximum point, okay? The next bit is the interquartile range. Well, that's very easy, okay? Just the upper quartile, take the lower quartile. Really, it's just testing your fact that do you know how you can read it off a box plot, okay? Now, remember, just off a box plot, okay? This is the lower quartile, sorry. This is the upper quartile, and this is the median. Okay, so you read down from what the upper quartile is, take away the lower quartile, you'd get 25 take 12, okay? So the upper quartile is 25, and the lower quartile is 12, so therefore the interquartile range is 13. Okay, so that's part B. So in ICC 2 marks, simply just reading the graph there. Now, if you hadn't spotted that was actually included, okay, well not spotted, actually realised that that was included, you still would have only lost 1 mark because it's not related, okay, part B is not. Okay, so going on to part C now. So the students were now asked to draw an angle of 70 degrees, okay, again without using a protractor, okay, so these were the results. Now, they've not told us the specific results, kind of like they did here, okay, they just told us it's somewhere between 55 and 60, okay, 6 students got that angle, okay, between 60 and 65, 15, between 65 and 70, okay, the students got 11, and 75 and 80, oh sorry, I've missed off a, that's brilliant, yeah, it's really brilliant, sorry, one sec, between 60 and 65, there was, between 65 and 70, there was 13, okay, I've missed off one, sorry. I thought I'd do this smart, but obviously it hasn't come out smart. But look, it is a whiteboard, so I can just rub it off. And between 70 and 75, sorry, there was 11 students who got that, okay. And then between 75 and 80, sorry, there was 8 students, okay. And then between 80 and 85, okay, there was 7 students. Okay, sorry about that, just missed off. Anyway, so I spotted that. Okay, so we're going to, for part C it says use linear interpolation to estimate the size of the median angle drawn. Okay, now it you could count all these up, 6 plus 15 plus 13, etc. But it's already told you at the start the 60 students. Maybe I do need to add it up. Okay, so there's 60 students as a total. Okay, and it's asking for the median. Now, as I say, we don't know the true individual angles they drew, but we know 6 students drew between 55 and 60, and the rest kind of follow that same pattern in terms of how many students drew an angle somewhere in that range. Okay, so as I say, we don't know, so we estimate. Okay, they're spread out evenly. Okay, but obviously that's not necessarily the case, but that's the best estimation we can make. Okay, your estimated guess. Okay, so the median, okay, is always, as I say, it's obviously the middle one. Okay, so you assume it to be the 30th number, and that's what I always write. Okay, so for part C now, we're looking at the table on the right. I'll kind of count that off for you. So what I always state is, okay, I say, well, the median is the 30th number, and I always go, therefore the 30th number lies in whatever range it does. Okay, well, quite clearly, if you add them up, it's going to lie in the 65 to 70 range. Just make sure. Sorry. God, have I done this right on here? Yeah, 65 to 70. I thought I'd done it wrong. I was a bit worried for a second. So the 30th number lies in the 65 to 70 range. Okay, but you might want. I mean, it might be helpful to put kind of, you know, cumulative frequency of the number of students next to it, if that helps you. Okay, so that's obviously 6, 21, 34. Okay, so it's 9 quite clearly, because the last person in this totaled the 21st student. Okay, it's 9 students into this. Okay, because we want the angle drawn by the 30th student. Okay, so it's 9 into that group. Okay, so you might have put it's 9 places into the 65 to 70 group. Okay, now as I said, we assume they're evenly spaced. Now the formula is for linear interpolation. I give a good explanation of why this formula exists the way it does. Okay, it's the lower bound, okay, which is in this case 65, plus how many spaces into the group, 9, out the frequency of that group, 13, times the width in that group, 5. Okay, now if you, as I said, I did a good explanation, but just a quick one now. Okay, as I kind of tried to explain, we assume this is spread out evenly. Okay, in other words, there are 5, there's a width of 5, okay, so each person has an equal width of that group. Okay, so each person has the same, so when you go into the second person, they've gone twice the width of the first one, if that makes sense. So if we were looking for the 13th student, we'd look at right at the end, so that'd be 13 over 13 times 5, plus the lower bound, that's the end of that group, which is 70. Okay, and we can look at the smallest number. So if we said we're looking at the first person into that group, well, if it's the first person, we generally assume that to be really sort of at the start of that group. Okay, so 65 plus 1 over 13 times 5. Okay, it's obviously quite clearly going to be quite low in that group. So it kind of works out on an even basis. But as I say, I do a great explanation. That was pretty shit, but I do a better explanation in the rest of the videos. But anyway, that's just a quick kind of guide. Okay, so it's just a case of plugging numbers into your calculator, and you should get the angle to be 68.5 degrees. Okay, because remember, these are angles drawn, so you need to write as such. So it's the 68.5 degree, okay, that's the angle which is drawn by the 30th student. Obviously, assuming this group is spread out evenly. It might not be, but we assume it is. Okay, so that's part C. Part D says, show that the lower quartile is 63. Okay, now the lower quartile is split up. So lower quartile is the first quartile. It's a quarter out of the whole set of students. Okay, so a quarter of the 60. Okay, is 15 obviously, 'cause it's half 30. So therefore, we're looking for the 15th student. Okay, now just as I did before, I label what group that student is in, and quite clearly, it's in the second group. So that's in the 60 to 65 group. Okay, but how many spaces into it is it? Well, it's a 15th student, and there's 6 in the first group. Okay, so it's 9 again into the second group. Okay, so it's 9 into the second group, and the lower bound of the second group is 60. So it's 60 plus 9 over the total in that group, which is 15, times the width of that group, 5. Okay, which, as it says, you're asking to show that the lower bound is 63, so that should come to 63, which it does. And not just because I say so, but it does in a calculator as well. It comes to exactly 63, even 33. So, you know, that's obviously right. Okay, So hopefully you get that. I'm just going to give you a second to copy that down if you do need to, because I'm assuming I'm going to have to make a little bit of room here. Okay, so hopefully you've copied that down. Right, okay, so for the next part it says, for these data, the upper quartile is 75 degrees, the minimum is 55 degrees, and the maximum is 84. Okay, so we're now told a few other bits of information about this data. Okay, now just before we're a bit off, actually going to note down these. Okay, so remember, part C we calculated the median. Okay, so we know the median of this group, we've just calculated it. So the median of the 70-degree angle was 68.5 degrees. Okay, we know the lower quartile, well, we've just worked that out, that's 63 degrees. Okay, and we've just been told the upper quartile is 75 degrees. Okay, the minimum recorded, okay, was 55 degrees. Okay, and the maximum was 84. Okay, so that's all the bits of information we're given, and there's something else we need to look at. Right, so all that extra bit of information is just in the paragraph just before it goes on to part D, okay? Or part E, sorry. Okay, so it says an outlier is an observation that falls either 1.5 plus the 1.5 times the upper quartile, interquartile range plus the upper quartile. So if it's an outlier on the outside of the range in terms of the upper, so past the upper quartile, it's the upper quartile plus 1.5 times the interquartile range, or if it's a lower outlier, okay, it's the lower quartile take 1.5 times IQR. Okay, that's what it's just saying there, but it generally will always state that. So you don't necessarily need to remember the formula for the outliers, but it is kind of helpful, as you can tell. Okay, so E part 1 says, show that there are no outliers for this data. Okay, so basically what we've got to do is work out the interquartile range, show that there's no values below, okay, so that the lower outlier, okay, the whisker, if you can think of it, this whisker, can kind of stretch to 55 as a minimum and 84 as a maximum. So if it stretches past that, these two maximum and minimum recorded values won't be an outlier. Okay, so basically what we've got to do is just do the lower outlier. Basically the lower outlier shows what the minimum angle would be if it were to follow this pattern. Okay, if these were all evenly spread, and that obviously would create a pattern, what's the lowest it could stretch, what's the lowest value we could see, or the highest value we could see, without it not fitting this pattern. So again, just a bit of a refresh on one of the bits there. Okay, so as I say, it's just about using the formulas. Okay, so it tells us, which it generally does. Okay, so the lower outlier is the lower quartile minus 1.5 times IQR. Okay, so the lower quartile, well, that's 63, take 1.5 times IQR. Okay, and the IQR is the upper quartile, take the lower quartile, 75 take 63, which is 12. Okay, so it's 63 take 1.5 times 12, which is 63 take 18, okay, which is 45 degrees. Okay, so anything less than 45 degrees would be a lower outlier, but our minimum value that we recorded was 55 degrees, so there's no outliers on the lower side. Okay, so we need to check if there's any outliers on the other side, on the upper. Okay, so for that one it's the upper quartile plus 1.5 times IQR. Okay, and the upper quartile we know is 75 degrees plus 1.5 times 12. Okay, and that comes to 93 degrees. Okay, and as our maximum recorded value is 84 degrees, you now need to put in a little sentence saying the minimum value could be is 45 degrees. Okay, which is smaller than our minimum recorded value of 55 degrees, and the maximum recorded value that we could record without it being a bit weird, okay, is 93 degrees, but the actual maximum value we recorded was 84 degrees. So there are no outliers in this range. Okay, and we're given another. So E part 2 basically is the next the bottom of the next page, okay, if you're going from the exam, there is a little small box, kind of like this, but obviously it's not got the box plot drawn on, and we're just asked to draw it, okay? So, because there's no outliers, we're not going to have to do any of these little crosses, okay? And just because it can go to that doesn't mean we've actually recorded that value. So again, just a little bit of information. Now, even if it hadn't mentioned that, okay, about the outliers, it just asked you to draw a box plot, you should have checked them outliers anyway, okay, because you will lose marks if you don't. Okay, so I think I'll probably just draw a little bit of a sketch before I continue this. Okay, so I've drawn, I mean, I know it didn't take long, but anyway, we've drawn the range on from 40 to 90 that they've given us, okay? So all we have to do is now draw a similar kind of box plot to this, but for our 70 angle degree, okay? So using all this information, with the median, 68.5, the lower quartile, 63, the upper quartile is 75, the lowest recorded value is 55, and the maximum value is 84. Okay, so quite clearly we start at 55. Now obviously you can be a lot more accurate than I can. Okay, so we've got 55 there. Approximately draw kind of the straight line that we had here. Okay, going up to the median. Now I put the median as 68.5 really, so you can put it on here, you would round it up, you would put it to about 69, okay? So again, another big spot there. Oh sorry, that's not gone well. Sorry, the lower quartile is the first line up, sorry. So at 63, you do your first line up, okay? And then the median is 68.5, okay, which you do at 69, okay, because you can't quite show it, 68.5. And then the upper quartile is at 75, okay, so you continue this box on for quite a bit, okay, up to 75. And then when you get to 75, you just draw a straight line up to 84 and then stop. And there's no outliers, you don't do any crosses, that's simply all you do. Okay, so quite a simple box plot that. And the next bit of the question is quite common after a box plot, okay? They will ask you, can you compare the two sets of data, okay? They'll give you a box plot for one, generally they will draw it and then ask you to do some calculations for it and do some calculations on the next one, draw a box plot for the second and compare, okay? Now quite clearly the first thing, well, it's not asking you to directly compare them. The words it says is, state which angle the students are more accurate at drawing. In other words, were the students better at drawing the 20-degree angle or the 70? Well, the first thing that you would mention, okay, this has got no outliers, okay, and this has. Now, I would expect something like that to come up kind of straight away, because you've just done quite a big question on outliers, okay, fairly in comparison to the rest of it, okay, so I would expect something on outliers to be popping up there. Okay, so something about outliers, so the fact that this has outliers and this doesn't, okay, so therefore the students are more likely, more accurate even to draw this, okay, than the 70-degree angle. So you mentioned about the outliers. Okay, and then the second one you mentioned it's about comparing the median, which were the closer. Now the next part I mentioned was about the angle you want in this one is 20 degrees, the angle you want in this one is 70. And the median for this one is greater, okay, is a greater amount from the actual desired angle than this one is, okay, because the median in this case was 68.5, which is very close to 70, okay. So the average student was better at drawing, getting close to the angle than they were when they did 20, and you'd expect that because the bigger the angle, the easier it is to draw to that angle, okay? So so I mentioned about the fact that comparing the medians, so median compare, okay? But as I say, there are loads of other variants you can have to compare, okay? But just using them to, you could say, as this has no outliers and the median is closer, therefore they're more accurate at drawing a 70-degree angle, and that's all you need to state, okay? So at the end of question 1, quite a nice question. I probably didn't need to pause it there, but you know, what's the harm? Okay, so thanks for watching. We'll see you in question 2.